Hi, my name is Hamad Fatih. Welcome to my channel. Today we are diving into database concurrency. What happens when multiple users try to update the same data simultaneously? We will explore the problems this creates and how Entity Framework Core solves them with a simple product example. Database concurrency means multiple users or processes accessing and modifying the same database record at the same time. The problems we need to avoid. Let's say we have a product with ID 1, name laptop, and price 1000. We have a one problem, lost update. Consider it as a admin A changes the laptop price to 900 while admin B changes it to 950. If both save at the same time, whoever saves last wins. The other person's change is completely lost. For dirty reads, consider admin A starts changing the laptop name but hasn't saved yet. Admin B reads this unsaved data and makes decision based on information that might never actually be committed. And the last one is data inconsistency. Multiple changes happening without coordination can leave your product data in an impossible state. But EF Core has some solutions. EF Core gives us two approaches: optimistic concurrency and pessimistic concurrency. Optimistic concurrency assumes conflicts are rare, checks for changes only when saving data. You can use row version property with the timestamp attribute. This SQL Server row version automatically changes every time the product record is updated. Alternatively, you can use the concurrency check attribute on any property, like putting it on the price property to check for price changes. This is useful for other databases like MySQL. When EF Core saves changes, it checks if the row version is still same as when you loaded the data or if the concurrency check property has changed. If another admin modified the property meanwhile, EF Core throws a DB update concurrency exception, telling you someone else changed this product while you were working on it. Pessimistic concurrency assumes conflicts are likely, likes data when a user starts working with it to prevent other users from accessing it until the first user is done. So this way locks the product record during updates using raw SQL, preventing other admins from accessing it until you have done. Most of the time use optimistic concurrency with proper exception handling. When a conflict occurs, show a message like this product was updated by another user, please review and try again. Then load the fresh data and show it to your user. Okay, I guess it's time to see some examples and understand all of this explanation. So I have three examples, one based on the timestamp, the other one concurrency check, and the last one the pessimistic way. So let's start with first one. I have a product record, ID, name, price. For this example, I want to show you row version. It should be a property with array of bytes marked with a timestamp. This is useful for SQL Server. It works automatically inside Entity Framework and SQL Server. So inside the DB context, also you can uh, introduce it as a is version, is row version. Okay, let me show you the simulator. This is a simulator for this example. So I just created the DB context for this product and inserted first record in the database. Name is test product, price is 50, and added and saved in the database. Now I'm simulating two users, creating two DB contexts at the same time, And in here, I'm looking for product. Okay. Now, user number one, try to change the name, price, and save it. It will succeed. And this will be our database scope, database values. But the second user try to change it, the product number two and price to 200, and save it again. Okay, because we found a record here, it's loaded before these changes. Okay, so to avoid this problem, we have to find the record again, but we want to simulate the situation. So I should get an exception, db update concurrency exception. Okay, so let me switch to the Microsoft website to show you something. In here, we have an article handling concurrency conflicts. And in here, the way for resolving, Microsoft has a really good example. Inside DB update concurrency, it's looking for entries and then the type of the record. For us is product. And then check the current value and database value. For each property, you can choose between proposed version, what client sent, and database version, what already database has. Okay, so you can choose client wins or you can choose database wins. This is a very nice way to handle this situation. Okay, so exactly based on this code snippet, I have created a simple uh, concurrency extension. So you can use it easier with different resolution strategy. In here, I have an enum, uh, client wins. I chose proposed values. Database wins, I chose database values, and custom, you can mix them. Okay, so in here, as you can see, this is exactly same code, but when I want to set them, I check the enum client wins or database wins, or something as a customized version you can write. I will show you some examples. So let's back to simulator. And in here, for the DB context, I call my extension method for this special record type, and I choose database wins. So what should happen? It means I should have what user one applied. So product one and 100 for price. Let's set a breakpoint and see the result. Okay, as you can see, we got exception. So we come to this one and we can call save changes again for a retry mode with these new rules. Okay, database wins for this one. Let's see the final result. And yes, as you can see, product is number one for user one and price is 100. Database wins. So let's switch to the other one. This time should client wins, means product should be number two and 200. Exactly. This is what we want. But also you can use your customized version. So let me uncomment this part. And as you can see here, you have a property entry, you have proposed value, the client, and database value. So for here, for property with name, I chose database value. And for the price, I'm looking for a maximum between proposed value and database value. Please don't mix value and keep your database consistent, but this is just an example. So we should have one information from user 1 and the other from user 2 because this one will be 200 exactly. So this is the way you can use a row version with the timestamp and handle a concurrency issue in uh, optimistic way. So it's useful when you have a web application with many concurrent user, really heavy workloads, when conflicts are rare, and when you can handle conflict resolution gracefully, like what we did. Okay, I mentioned there is another way, so let me switch to another one. This time, instead of using the row version, we want to use a concurrency check. It's useful for non-SQL server databases like MySQL. In here, you need a version, property, and type can be long, GUID, or even datetime, okay? But long is one of the best. So I have also a DB context here, same as before, but this time you should introduce it as a is currency token. You can mark in here as an attribute or define it in here. Important thing is who will update this version. When it starts, it's 0 and it should be increasing 1, 2 until to the end. Okay, so we need to have an approach to increase the version. So I have created a apply version functionality. So I'm looking for entries, check them if they are modified or not. Then I got the original version and the current value. I check the user shouldn't uh, change the version. It's very important. It should happen automatically behind the scene when we save the changes. So I will raise an exception. And in here, I just increase current value with 1. But it's possible at this specific moment we have a race condition issue because DB context and save changes are not thread safe. So we need to do something. For the sync version of apply versioning, I have a lock block. The value and the variable is here. Okay. And we need also asynchronous version of it. So for async, lock doesn't work. So we need semaphore slim for this one. So I have an async version, as you can see with semaphore wait async and release. How we should call this? We need to override save changes and save changes async and call apply versioning before the base save changes functionality. By doing this, we are able to handle concurrency check by increasing the versions. So let's back to simulator. This one is same as before, exactly same as before. So nothing will change when you are working. So don't need to check database wins and client wins. Let's just check the custom one. And same as before, we should be able to see the mix of results. And as you can see, this happened. Just for making sure this concurrency exceptions raised, let me rerun it. Exactly. Same error, same problem, and we had the same result, but this time instead of the timestamp, we use the concurrency check. Okay. Until now, we discussed about optimistic concurrency. Now I want to show you something else, pessimistic concurrency. So this time I have a product without any special property. And in here also, I have nothing special, just my uh, database model and DB context. But simulator will change a lot. For pessimistic, I will simulate user 1 and user 2, and I will run them with when all. So in here, for simulate user 1, we need a transaction. For pessimistic concurrency, we need a transaction. We should start this one. And then we need to lock the record. Okay? To this, we need to apply from SQL row on the DB context and execute this query. This query is for SQL Server. My example is based on SQL Server. For the other databases, you need a bit different. As you can see here, it's for a Postgres, MySQL, and Oracle. So you somehow add this as an extra things on top of your DB context and save changes. This will lock your record, so you will try to update your record, and afterward it will release the lock and the other users can use it. So in here we did it. We have a delay just for simulating some processing time, and the values for product 1, 100, this happened by user 1. Save changes and commit. Exactly, I did this for user 2, so but with different values. So in here, when I call those concurrently with when all, I have a bit delay to make sure the user 1 starts first and then user 2 tries to update the records. So now let me run an example. As you can see, user 1 attempting to acquire lock, user 1 did it, then user 2 tried attempting to acquire lock, but didn't happen really, because user 1 locked the record and completed the update. Now user 2 able to acquire the lock on product and completed the update. So the final will be what user 2 applied, which is completely correct, but they did in serialization way to update the record. So nothing happened as an issue, a concurrency issue here. Pessimistic concurrency can use in financial transaction where conflicts must never happen, critical data that can't afford conflicts, when conflicts resolution is too complex, in batch processing systems, you can use the pessimistic concurrency, but most of the time, optimistic way is the best one. That's it. If you found this video helpful, please hit the like button, subscribe for more coding tutorials, and leave a comment if you would like to see more. Thanks for watching. I will see you next time. Take care and goodbye.